Hey, hello everybody. I'm Elliot with Team Nine, and our group is myself, Miriam, and Erica, and we did our project on global population growth. Um, so, the question we have, excuse me, let me move this out of the way. Is there a relationship between a country's landmass and a country's population growth rate? If so, how does this relationship contribute to the global population growth rate? So the question we had was basically, does the landmass of a country correlate with their population size? The way we went about trying to answer that question is we were using different graphs that we created a visual comparison to the global population growth rate and of individual countries' population growth rates. So we could see if there was a relationship to countries with larger landmass, possibly larger country population growth rates, leading the overall population growth rate. We can also compare the size of a country's landmass to that of its population to see if landmass is a determining factor to the rate of growth of a population in that particular country. So, like I said, we were just trying to see if there was a correlation between the size of a country and the size of their population. In our data set, we decided to include the country's rank based on population size, their landmass, their growth rate on average, the percentage of growth rate, their population density per square kilometer, and a projected global population of 10 million. In our data sets, we had a 1% average of individual country population growth rates. So, I mean, there was some fluctuation, but that was the average. The most populated country was India with almost 1.5 billion people. And the country with the largest landmass was Russia, which right there, you can see the difference that there was a country that's highly populated that has maybe 40% of Russia's landmass. We did a density of people per kilometer. So we took the landmass of the countries and divided by their populations, and we averaged globally 58 people per kilometer. And then we also projected out a timeline when our population would reach 10 billion globally, and that was 2053. So the way we went about doing our study is we wanted to make sure we were as objective and impartial as we could. And by working together and having a defined goal, all being on the same page, we checked each other, during the project for errors and data inputs, maintaining an unbiased sample, and we understood the limitations of our study to avoid making any possible decision-making errors. And by being objective and not subjective in our findings and results, we maintained awareness to avoid cognitive biases. We didn't want any of our own biases interfering with the results. And a couple biases, cognitive biases that easily could have presented themselves with this particular data set was the confirmation bias and the availability heuristic, which, this is going on previous information and not updated information. So first, we need to know, is it as simple as landmass equals a large population? So does one variable affect the other? So the first graph keeps it pretty simple. It's like the first test to see if there is a correlation, and it's which country has the highest population. If the country with the largest landmass had the highest population, we'd be looking right at Russia, which is right above China there. But you can see they got a huge landmass, but they got a little bubble, which obviously means there's the landmass is not making that bubble any bigger. So finding one, data shows that India has the highest population, which is the slightly larger bubble next to China, and you can see India's landmass, and still has the highest population. Next, I'm going to hand this off to Miriam.
So, does the amount of land in a country affect population size? For this finding, we are comparing the land of a country versus the population size. The data visual shows that population size has no correlation to the country, the land of the country. The visual on the left shows Russia showing the largest landmass, and then the amount of land has no relationship to the country's population size. The second graph, how do individual country population growth rates compare to the world population growth rates? For this finding, we have the graph on the left, which shows the world growth rate versus the population growth rate. On the left, it is based on the measure of growth rate on a scale starting at 0.044 going to the negative of negative 0.76 versus the graph on the right that shows how do individual country population growth rates compare to world population growth rates. It's gonna be showing the population in 5 different years, starting at 1990, starting at 1980, going to population of 2023. And it shows individual country population growth rates on average are about the same as the world population growth rates. The next graph is when can we estimate the population to reach 10 million? So we did a regression line based on the data to calculate the forecast of when the population will reach 10 billion. And we found that in 2053, the population will reach 10 billion.
Elliot said earlier there were some cognitive biases that we had to take into consideration when looking at our data set as a whole. But when it came to creating our graphs and our data visualizations, we also had to look a little more deeply into the content of the data set. So one important thing that we noticed was that the data was taken from sample years with a different gap in between them. So we're looking at 1980, 2000, 2010, 2022, and 2023. And relatively, those are uneven gaps of 20 years, 10 years, 12 years, and 1 year respectively. So we had to keep those factors in mind when we were deciding how to take that data and use it to find our linear regression and other information. Secondly, we had some projected data values that were already in our data set. So we had to take that into account to know that they may not be entirely accurate given those previous gaps. And so we had to look at the trend line in a couple different ways. And thirdly, the questions used to complete the findings, they needed to be correctly labeled because we were using a significant amount of data coming from different sources and also different statistics in the findings to come to our conclusions. So the solutions, in order to find the solutions to our findings, we looked into utilizing the data set to research the global population. In addition to researching, we were able to use the data to make predictions of population growth, see using data trend lines. And there were key factors in our analysis that gave us the opportunity to compare the data of global population between countries, and contributing factors, including landmass. Our data demonstrates the global population growth as increasing exponentially. And finally, our conclusion. Each of our findings did have a solution. So I'll reiterate that finding number one. We found that the country with the largest population globally is India. And finding number two, the country with the highest population growth is Syria, and the country with the most negative population growth is Ukraine. Finding number three, the amount of land does not affect the population size. There's no correlation between that. Finding number four, the world population growth rate directly corresponds to the cumulative average of individual countries' growth rates. And finally, finding number five, we have estimated that the population will reach 10 billion by around the year 2053. And for our final slide, it's the site for where we found our data. That was our important data set that we used for all of our findings here. Thank you for watching our presentation on our global population.